Future of computers. So, computers are becoming increasingly popular and they are continually improving as time goes by. The future of computer would be a quantum of computing or a quantum of computers rather. So, what is quantum of computers? According to Donna Lu, quantum computers are machines that use the properties of quantum physics to store data and perform computations. In quantum computer, the basic unit of memory is quantum bit or qubit. And according to Holton William Coffin, quantum computer is a device that employs properties described by mechanics to enhance computations. And also, according to Donglu Shi, Shizing Gu, Nicholas Bedford, quantum computer is a class of physical devices that can perform high-speed mathematical and logical operations and that can store and process quantum information.
Based on my analysis in computers, there's a lot of possibilities that a computer would grow and evolve in the future. Even computers nowadays has a big impact in our world. It is like the ones who are inventing the new computer is not that contented on the function of the recent computers. It is more likely there's an inadequate on it, that's why they are inventing a new one to make it feasible. There is a theory that quantum computers will be the future of computers because of its speed in computing and analyzing. It also reloads faster the sites, videos, and games due to its speed. So these quantum computers performs quantum computing, which is a type of computation that harnesses the collective properties of quantum states such as superposition, interference, and entanglement to perform calculations. Unlike on the computers today which manipulate ones and zeros to crunch through operations, but quantum computers use quantum bits or qubits. Just like classical computers, quantum computers use ones and zeros, but qubits have a third state called superposition that allows them to represent a 1 or 0 at the same time. Also, Google announced that a quantum computer is 100 million times faster than any classical computer. We can say here that quantum computers is better than any classical or recent computers. To make it short, quantum computers will be the future of computers. It is faster than any classical computers and could even make our works faster, especially in computing which use qubits.
The world's biggest companies are now launching quantum computing programs and governments are pouring money into quantum research. For systems that have yet proved useful, quantum computers are certainly guaranteed lots of attention. Quantum computers offer great promise of cryptography and optimization problems, and companies are racing to make them practical for business use. From simulating new and more efficient materials to predicting how the stock market will change with greater precision. The ramifications for businesses are potentially huge. Here are some of the uses of quantum computing. The discovery of new drugs. This relies in a part of a field of science known as molecular simulation, which consists of modeling the way that particles interact inside a molecule to try and create a configuration that's capable of fighting off a given disease. This is why discovering new drugs takes so long. Scientists mostly adopt a trial and error approach, in which they test thousands of molecules against a target disease in the hope of a successful match that will eventually be found. Quantum computers, however, have the potential that one day resolve the molecular simulation problem in minutes. The systems are designed to be able to carry out many calculations at the same time, meaning that they could seamlessly simulate all of the most complex interactions between particles that make up molecules, enabling scientists to rapidly identify candidates for successful drugs. Next is creating better batteries. From powering cars to storing renewable energy, batteries are already supporting the transition to a greener economy. Their role is only set to grow, but they are far from perfect. Their capacity is still limited and so is their charging speed, which means that they are not always a suitable option. One solution consists of searching for new materials with better properties to build batteries. This is another molecular simulation problem, this time modeling the behavior of molecules that could be potential candidates for new battery materials. Similar to drug design, therefore battery design is another data-heavy project that's better suited to a quantum computer than a classical device. Quantum computers can also be used to predict the weather. Despite the vast amounts of computing power available from today's cutting-edge supercomputers, weather forecasts, particularly longer-range ones, can still be disappointingly inaccurate. This is because there are countless ways that a weather event might manifest itself, and classical devices are incapable of ingesting all the data required for a precise prediction. And because quantum computers would be able to analyze virtually all of the relevant data at once, they are likely to generate predictions that are much more accurate than current weather forecasts. Last year, for instance, the European Center of Medium-Range Weather Forecast, or ECMWF, launched a partnership with IT company Atos that included access to Atos quantum computing simulation in a bid to explore how quantum computing may affect weather and climate prediction in the future. Quantum computers can also be used in the financial field, such as the stock markets. Some people are all actively investigating the potential of quantum computers to improve the efficiency of banking operations. A use case often put forward as one that could come with big financial rewards. There are several ways that the technology could support the activities of banks, but one that's already showing promise is the application of quantum computing to a procedure known as Monte Carlo, which could boost Monte Carlo calculations by up to 1,000 times. According to research carried out by Goldman Sachs, together with quantum computing company QCware, in even more promising news, Goldman Sachs quantum engineers have now tweaked their algorithms to be able to run the Monte Carlo simulation on quantum hardware that could be available in as little as 5 years' time. Quantum computers can also be used in reducing traffic, optimizing the time of traffic signals in cities so that they can adapt to the number of vehicles waiting or the time of the day could go a long way towards smoothing the flow of vehicles and avoiding congestion at busy intersections. Quantum computers could assess different scenarios at the same time, reaching the most optimal outcome at a more rapidly state. Researchers have begun developing quantum-inspired algorithms in a simulated city environment with the goal of reducing congestion. Lastly, the most critical aspect of quantum computers: protecting sensitive data. Modern cryptography relies on keys that are generated by algorithms to encode data, meaning that only parties granted access to the key have the means to decrypt the message. The risk, therefore, is twofold. Hackers can either intercept the cryptography key to decipher the data, or they can use powerful computers to try and predict the key that has been generated by the algorithm. This approach requires extremely powerful computers and isn't considered a near-term risk for cryptography. But hardware is improving, and security researchers are increasingly warning that more secure cryptography keys will be needed at some point in the future. One way to strengthen the keys, therefore, is to make them entirely random and illogical. In other words, impossible to guess mathematically. And as it turns out, randomness is a fundamental part of quantum behavior. The particles that make up a quantum processor, for instance, behave in completely unpredictable ways. This behavior can therefore be used to determine cryptography keys that are impossible to reverse engineer, even with the most powerful supercomputer. Of course, risks are still unavoidable. Quantum computers have the capability to create multiple random encrypted algorithms. However, quantum computers can also do the opposite. Quantum computers, when perfected, can easily break normal binary-based algorithm encryptions with ease. This is because the quantum computers can process data at massive speeds. Present encryption will seem useless to a quantum computer. Now, in today's time, following the hype of quantum computers, it is inevitable that sooner or later that we will be using this technology. That's all. Thank you.